Okay, a lot of you guys are super confused with regards to the stretch or shrink, so I'm going to go over a couple things on that when creating the equation. So if you are stuck on stretching and shrinking when writing an equation, this is how you do this. So if you look at a standard parent function graph, that would be y equals x squared. So when I plug that into the parent function graph and I use -2, -1, 0, 1, and 2, this -2 squared will give me 4, -1 squared will give me 1, 0, 1, and 4. Okay, so when I graph that, that's going to look like this. And then again, over on this side, it doesn't really matter, but that would be your parent function graph, which is in green. Now, if you look at this, if I go from this point to this point, because I'm starting only at the vertex, you always start at the vertex of what you need to do. So you're going to look at the vertex right there, and you're going to look and see how much is it going up and over to get from that point to that point. Okay, and this is considered a pretty point because it's 1, 1. If you guys understand that, that's 1, 1. So that is considered a pretty point. So I'm going up 1 and over 1. So that tells me that the parent function does not have a stretch or shrink. Now, if I look at the actual graph of this one, this right here is my vertex. Okay, if I go up 1, it's not going to go over 1, it's going to be right there. So you've got to figure out where's the next pretty point on this graph. Well, the next pretty point is going to be right there. So how much am I going up? 1, 2, 3, and then I'm only going over 1 because you're thinking of it as a slope. So for the equation, the vertical stretch, why do I know that it's a stretch? Because it's getting skinnier, is going to be 3. Okay, so if you were to write your equation, this vertex is going to be 2, -6. Okay, so in vertex form, if you were to write this equation, it would be y equals, and again, it's happy, so it's going to be a +3. Then it's going to be x -2, because my vertex is 2, -6. My axis of symmetry is 2, so it has to be opposite. And then square that, and then it'll be -6. That would be the equation of that specific graph. Okay, if you go back up here and you look at this, if I look at the vertex and the next point over on there, do you see how you go down in 1 and over 1, and that's a pretty point and a pretty point? So therefore that has no stretch or shrink. Okay, a couple more that I will do with you guys. I think it's on lesson 9. Okay, I'm going to jump over to lesson 9 real quick when we put it all together. This one on number 10, a lot of people had questions on that. I definitely want to go over that for you. If this is your vertex, okay, if it was standard width, you would go over 1 and over 1 and down 1 and over 1, sorry, and down 1 and over 1. So this would be the standard width of the parent function. Obviously it's SAD. Okay, so it's going to have a leading negative. But if I wanted to find the stretch or shrink for Jake's graph, which is this parabola right here, okay, I'm going to look at the vertex, which is going to be this point right here. And then what is the next point? You can use this point or this point. So if that is a stretch, we know that it's a vertical stretch. S-T-R-E-T-C-H. Sorry, if it's a vertical stretch, I know that I have to go from this point to that point. I'm going to go down 1, 2, 3, 4. So this has a vertical stretch of 4. So again, going back to the equation, your vertex is going to be 1, 10. Your equation would be y equals, and because it is SAD, you have to put -4, because the negative tells you that it flips upside down. Then it'll be x, and then the vertex is 1, so it's going to be -1 squared, and then plus 10. That would be your equation. Hopefully this clarifies things on how to do the vertical stretch and shrink. You're only looking at the 2 points from one distance apart on the x-axis. If you have any other questions before the test, please email me.